In this video, I'm going to look at two financial functions. One is the payment function, or PMT, and the other is the future value function, or FV. And these functions actually share arguments. Some of the arguments are the same. So I wanted to do a quick overview of those before we actually work on the functions. Rate is the interest rate per period, per payment, in other words. And usually when you are quoted information about a loan, the loan rate that they give you is an annual percentage rate. So in the actual function, you have to divide that percentage rate by 12, and we'll take a look at that in just a minute. The N per function is the number of payment periods. That's the total number of payments that you would make on the loan. Present value is the present value of the investment, how much you are borrowing if it's a loan, or how much you have already invested if it's an investment. When we'll look at an example of this as well. Future value is the future value of the loan or investment, and with a loan you would expect the future value to be 0 because you want to totally pay it off. With an investment, the future value is going to be the goal that you want to reach, how much money you want to save, or how many shares of stock you want to have, or whatever it happens to be. Now the last, future value and type, in the payment function are optional arguments. If you don't put anything in those boxes, or in for those arguments, they're assumed to be 0. Type specifies when you make the payment, whether the payment is made at the end of the month, for example, or at the beginning. So at the end it's 0, and at the beginning it's 1. So let's go ahead and do a payment function in our worksheet. And this is the Lesson 11 workbook. I unhid the CU worksheet, which was hidden, and entered some information in here for the loan and for the monthly savings plan. So in cell C12, I'm going to calculate a payment on a car loan made at the beginning of the month. So to find the payment function, I'm going to go to the Formulas tab, to the Function Library, to the Financial Functions, and scroll down, and it's this one here. And so you see the arguments that we were just discussing. First one is rate, and I'm purposely going to calculate this payment without dividing my rate by 12 to show you what a difference it makes. So I'm going to click on the interest rate, and then the number of payments, and then the present value of the loan. Future value I'm going to skip because Excel will assume that to be 0. And the type I'm going to change to 1, which represents a payment made at the beginning of the month. Then I'll click OK. Now here's what I want you to stop and think about. This is a car. You've borrowed $20,000 for 4 years, or 48 payments. So without calculating interest, if I just take that 20,000 and divide by 48, I come out with payments of approximately $420 a month, give or take. So I can see just by doing that about where my loan payment should be when I complete this function. And I can see here, because I purposely did not divide C10, the interest rate, by 12, that my payment is way too much. This is more like a mortgage payment than a car payment. So I'm going to go ahead and edit that function so that I'm dividing the interest rate by 12, which is the number of months per year or the number of payments per year. And look what a difference that makes. It's 457 as opposed to 1,000. Okay, so let's see what difference making a payment at the end of the month would make. And this time I'm going to use the keyboard to enter the function. So I'm going to start out, of course, with equals and then type PM. There's the payment function, so I can press tab to get that into the cell. I'm then going to enter my first argument, which is the rate. And I'm going to be sure to divide that by 12 because I know it's an annual percentage rate. Then type a comma, and I'm on to the next argument, the number of payment periods. Comma, and you've got to be very careful to put in these commas when you're typing a function, because if you don't, your function won't work correctly. And then my final argument will be the present value. And as you can see, as I'm typing these arguments in, Excel is coaching me by making the current argument bold. Now, since this payment is at the end of the month, and since I ultimately want my loan amount, or that amount, to go down to 0, I'm not going to enter anything for the future value or the type. Excel by default will assume those two arguments to be 0. So you can see there's about a $2 difference between the two amounts. Okay, let's switch gears and look at the future value function. And over here is a monthly savings plan. And the person is planning to save for 5 years, making a monthly deposit of $50. And they're starting out with $1,000 in the account, and the assumed interest rate is 3.25%. So what we want to do is figure out how much money will be in that account at the end of 5 years. So we're going to use the future value function, which is also a financial function. So I'm going back to the Formulas tab, to the function library, to the financial functions, and I'm going to choose FV. Let's drag that out of the way so we can see. So the first thing again that I will enter is the rate, and this really looks pretty much like a payment function. So the rates again still needs to be divided by 12. The number of deposits that I'm going to make is the number of periods. So I'm going to make a total of 60 deposits. And the payment is the amount that I'm going to deposit each month. And Whoops, I forgot to move forward there, excuse me. And then I have present value and type. Again, present value is taking the place of future value in this particular function. Again, these are optional arguments, and I know that because they're not bold. But I do have a present value for the savings account. It's $1,000, and that information is stored in cell H10. And then the type, again, it depends on whether I'm making the deposit at the beginning of the month or at the end of the month. So for this particular savings plan, I'm going to make that deposit at the beginning of the period. So I'm going to type a 1 in the type box, and I'm done with my function, so I'm going to click OK. So we see at the end of 3 years, or 5 years rather, we'll have about $4,400 in the bank. Now you've probably noticed that the results of these functions are in red, and Excel uses the red formatting with the parentheses to represent a credit or a cash outflow, because these amounts would be being paid out of your main bank account. So there's a couple of ways that you can make these look like positive numbers, particularly over here. I could make the loan amount negative, which makes both of these numbers positive, or I can add a minus sign between the equal and the function name, which also has the effect of making it positive. Now, as for the formatting here, how these numbers show up, you do have some choices that you can make. So if you go back to the Home tab, to the number group, and launch the dialog box. These are currency, so you see the various formatting choices that you have for currency, and these are the different ways that you can show negative numbers in your worksheet. And typically in accounting worksheets, negative numbers are shown with parentheses around them. They aren't necessarily red. So if we want to use that format, then I would just click on it and click OK. And there are other formats that you can choose for negative numbers. Next, we'll revisit data validation with a new type of rule.